Good afternoon, everyone, and welcome to the next presentation of today's MWB High-Tech Engineering Conference. I'm happy to welcome Markus Ehret, member of the Executive Board of Singulus. A housekeeping note: the conference is being recorded and all participants are in listen-only mode. If you have questions for the Q&A session, please submit them using the chat box at the bottom of the screen. Now let's get started. Mr. Ehret, the floor is yours.
Thank you very much, Mr. Hoyan. This is Markus Ehret speaking. A warm welcome from my side to the audience. I wish you a pleasant afternoon, and I look forward to receiving your questions at the end of my presentation. And I will walk you now through a couple of slides. As we are more than 30 years old, I guess many of you are familiar with Singulus. But however, I'll give you a brief introduction to Singulus. What you see on the beautiful little picture, these are our premises, our headquarters in Karl am Main, close to Frankfurt. And we are a leading provider of high-tech, which is used, we will see that later on, in the field of semiconductor, in the field of photovoltaics, and in life science, medical tech. And as well, we are moving also towards other industries. You'll learn about that. Please understand that we are solely an equipment making company, so we're not producing products, final products. This is up to our customers. We are making equipment. And also please understand that our equipment is right at the heart of the production of our customers. So our customers basically all our equipment which define their product. So we're not doing some lasering or some automation, moving things from left to right or something like that, which might be exchangeable. Typically, our equipment is hard to exchange once the customer has decided to work with us. And typically also it takes quite long to develop the new processes on an equipment platform. And we always try to work with leading technology, leading companies in all the segments, and you will learn about that later on. So this is the core of our business model. We're an equipment making company and right at the heart of the production of our customers. This is why we're doing R&D and engineering and design. This is where we are making our money. We have an assembly and a very, very low depth of production, meaning that we are doing the design and the construction of parts, and then we hand out the parts, and some even groups of parts come back pre-assembled, and then we assemble the modules and the equipment and commission that, and then we ship it to our customers, commission it again, and bring the processes, the production processes upon our equipment. So we're making our money not in producing parts, but we are making our money in R&D and in design and in software and in processes. This is where we make our money. So where do we do this? Or what is it supposed to mean? Many of you might know that we've been the world market leader for optical discs production, for production equipment for optical discs. Our space line is legendary. That was the machine. Also, our blue line was legendary because we had basically 90% market share in the Blu-ray business at the time. So the core competences, however, what we have, you see on this page. So what we learned to do in the old days and what we are now applying to new fields and new areas of production equipment is the thin film deposition. So we are able to deposit very, very thin layers of materials. And this is used, for example, in the semiconductor industry, also in the solar industry. And we're using different technologies. You can see that on the left side of the slide. It's basically, we do sputtering, PVD, it's PECVD, it's evaporation. And it's not just that we are using that type of technologies, but the precision we are applying to those surfaces, to those new deposition layers is very, very high. So in some areas we speak of, we will see this later, of nanometers down to angstroms, and you will learn about that later on what it means. So thin film deposition is the core, it's vacuum business. We also do surface engineering. We can do layering, embossing, meaning we can create micro nano structures on surfaces with a very high precision, which is used also in med tech, or with lacquering, which is used in consumer goods. Wet chemical, we can do cleaning, washing, etching. We can do texturing. This is used very important in PV, photovoltaics. Yeah? So we are one of the leading wet chemical companies in PV in the Western world. And now that we will discuss that later on, we can see that the PV is coming back in the Western world, because right now everything is with the Chinese. Things are coming back, and we will see that this is a very interesting part. Thermal processing also, we can do thermal processes under vacuum or very, very specific atmospheric very, very characteristics. So meaning that the thermal processing, heating up and cooling down under vacuum, this is really high tech, and especially if time is of essence, we have to, if you have very time critical processes, or you want to have high throughput, this is what we really can do. So those are the core competencies we have, and we have applied that to a large area of equipment, and that's the portfolio. You have to consider this as a portfolio. So of course we're proud of our processes. We're proud of having a large area of machines, large portfolio of machines. However, of course, we have platforms and modules. On the platforms, we are using those horizontal sputtering platforms or vertical platforms for different processes, for sputtering or for PECVD in different industries. So it's like a toolbox, or like Fischer Technique, for the Europeans, Märklin. You have a set of equipment which can be arranged and can be used in different areas, different areas of industries and different demands from the customer. So we will discuss that later on. You will see, as I said, in the semiconductor area, we do this not only in micrometers or nanometers, we go down to angstroms for the non-physicists among us. So it's a nanometer is a billionth of a meter, and angstrom are single atomic layers. So we can do single atomic layers, and on a 300 millimeter wafer, this has to be a very, very high precision. And so the picture to imagine what that means is, if you were losing or dropping a golf ball in Belgium, on the country of Belgium, that's a pit or a hole which is not supposed to happen, which must not happen at that stage. So because the layer has to be very, very precise, and we can do that with that precision demanded by our customers. So that's, I'm sorry, I jumped too far ahead. So this is, this is the Timaris. This is our semiconductor platform. And basically it's a cluster tool, meaning that you have a central handling system. And to this central handling system, which can have 5 or 4 ports, and to that central handling system, you apply modules, and in those modules, different processes may be applied. And with those different modules, you can see this on this page, then the customer can decide what type of product, what type of he needs to create his own products, what type of product he's doing. And that is basically what our machines are doing right now. We have a very strong market position in the inductor for integrated voltage regulation. This is a very good product, and we do see that there's a growing demand for it. Also, we are moving into packaging of interconnection, and of course, like magnetoresistive random access memory or resistive random access memory. This is what we do. TMR, XMR sensors, also very interesting. This is basically magnetic sensoring based on semiconductors. So this is a very interesting area because you can do very small, very precise sensors. And in a car, like in the new cars, especially in the electric cars, you need hundreds of those sensors for various, it's the eyes, the ears, and the distance regulation. So, and pressure regulation, voltage regulation, you can measuring the voltage. So this is very important, and we do see an upcoming and growing demand for that type of equipment. So semiconductor is an area we look very much forward to and believe that there's a good future for us in this, especially as we see that the Western markets are also coming back right now. We sell a lot of equipment to the Chinese, but we do see growing interest and early adoptions also in Europe. I think it's a long shot although, but in the next 5-6 years, we do see that some production in this area is coming back to the United States and also to Europe. In medical technology applications, we do a lot of washing, etching, cleaning, and cleaning. You can see the machine on the next page. We have here specialized equipment to clean contact lenses. They are made from polymers, and the polymers need to be cleaned after the production. And this is what our equipment does. And we have two very large customers in this area. You know, the world market is basically dominated by 5 large producers of contact lenses, and 2 of them are our customers, and we're in very good contact with others in this market. And we hope we can extend our market share in that market. And it's a very interesting product, and especially as the medical tech market as itself is a very profitable market. This also helps the equipment making companies. Why? Because the customers are basically looking forward to get highly reliable and highly efficient equipment with very good yields, uptime, and they are willing to pay for a good quality, not just for the lowest price. They go for good quality. They want to see made in Germany. They want to have the best software, MES systems. So that's for us, it's a USP that area, especially as we have now also the GMP, the good manufacturing processes, so that we have all the documentation in place which you need in the regulated industries. Let's move on. This is high volume production systems for the consumer goods. Also very interesting. It's for us, let's say, rounding a product portfolio, and we can do very high throughput equipment and a very interesting market. However, it will stay a niche market for us, and but it's sputtering, it's lacquering, and this is what we can do, and we're selling that type of machines to our customers, and we do see a good and stable demand for those type of equipment. However, this also kind of is related to the global GDP growth. So if more consumers are produced, we do see a growing demand. If the economy is slower, then it's also slower. We have very large inline, thin film, and other glass applications. As I said, based on our platforms. This is the Canaris platform. You can see here horizontal platforms. But where we use this, we do use this in the area of photovoltaic. And not only that, we have very specialized, highly efficient single equipment, but also we are capable of delivering a turnkey solution for heterojunction, high efficiency cells based on crystalline material to our customers. And as you know, 95% of the world market right now is in China with the cell production, wafer production, cell production. And we do see that the Western world is kind of turning around and wants to have back at least a certain percentage of local content, meaning that there will be solar cells produced again in the Western world. And if you have let's say, interested customers moving into that field, then they need partners on the process, on the equipment side, who are capable to address their needs. And their need is like a turnkey fab. We can deliver that turnkey fab because we're delivering not only the equipment, but also the process with along. And this is a very good value proposition, which helps us a lot. And we expect that in the next, let's say, 2, 3, 4 years, there will be a growing demand because some of the production will be coming back from China to the Western world, be it Europe or what we think is that the US is the first to deploy that. We are also in a very new technology in the PV market, that is perovskite. It's a very special material, and those layer stacks of perovskites can be evaporated, and we have a very strong expertise in evaporation, and we are in touch with some of the most innovative or inventive equipment solar cell makers in the world using that technology. And we also do see that we have a chance of picks up on an industrial basis. We can deliver some equipment for the production of those type of solar modules based on perovskite. So our strategic business development is on the combination of vacuum deposition technologies and wet chemical technologies, and bringing those together and bringing them together in all production lines and production processes is a very unique selling proposition for us. And we're one of the only few companies in the world who can do that. And we do see some customer interest for that type of knowledge we have, process knowledge we have. And we hope we can generate more business on this in the future. And we want to strengthen our profile in the area. Where is this also used? Well, the upcoming fields are like fuel cells and electrolyzers. The whole hydrogen market will be coming. While the fuel cell might still be a little bit a future theme, if we are in touch with some of the largest automotive supplying companies in the world, and they give us the feeling that the fuel cell technology needs some time. However, there is niches like in trucks, but for the larger let's say personal vehicle market, it's not the first choice of technology right now. So, however, what comes up will be the hydrogen for industrial usage. And here we are working also with some of the leading companies, because what they need is coating technology for their electrode in the equipment. And we just have sold 2 products, and one to a very large company, it's an international company who wants to move his electrolyzing business based on our coating technology for the electrodes. And we look very much forward to that, because the process has been proven, the technology, our equipment is proven, and we do believe that our customer will be highly successful, and we want to be part of his success. So we look forward to working with those guys. Of course, we are also looking into new markets in this area. So we have been working with one of a subsidiary in the United States of one of the very large OEMs, European OEMs, who is in the next generation batteries, solid state batteries. This is still an area which can explode which can stay, because the lithium-ion batteries are also growing, and the technology is also moving very fastly forward. So we will see what happens, but we are in touch. We are close to the process development, close to the equipment. I've delivered some equipment for the prototyping lines, for the solid-state batteries. And if this picks up with this large OEM, we can also be part of that story, and we look very much forward to it. So another issue we look into is the carbon capture industry, because it's the type of equipment and the type of processes we have at our portfolio, and we work with at early stage with first interesting partners, and let's see what technology will be leading in this edge, and we can supply them with the first class equipment they need. So this is basically where we are. This is what I wanted to give you a glimpse of or a glance of. We are in very interesting markets. We are driven by innovation and technology, and you have to know that the upside is really that we are at the heart of the production process of our customers. So once they define their product and they have used our equipment, they typically stay with us. However, we are so tied to that then that if our customer is not moving forward in the production or mass production, well, then we kind of lose also a lot of time, because the development of processes, production processes based on our equipment takes also years. Of course, we get reimbursed from the customers. However, we don't get rich by R&D. We money if our customers are very successful and then are ordering 10, 15, 20, 30 machines. And if we can produce those, that's a lot of money. That's a lot of free cash flow. And if one of the issues I just mentioned earlier in the last 20 minutes, if one of those topics picks up and moves forward, then we have a very good future. And this is what we're looking for, that we are at the right time, right spot, with the right technology, with innovative processes, with our customers at the side of very large global players, and which we can swim along, and they are blazing the trail and we move along with them. And this is the strategy basically we have in our areas. So as time is moving forward and we have like another 5-6 minutes for Q&A, I would ask Mr. Bojan to get back and see if there is some questions coming up from the audience, and I'll be very happy to answer those questions.
Thank you, Mr. Ehret, for those insights. And indeed, we already have a number of questions. So let's get at it right away. So the first one is, will your semiconductor business be the main driver for your business in the future? What application offers the highest growth opportunities, and what is the competition in this space?
So the question was, where's the biggest potential in semiconductor, basically, right?
Yes, I would say it's actually two questions. So the first one is, what is the potential semiconductor, and what maybe other application could have the highest growth opportunities, and what is the competition in this space?
So what we do see right now, I mean, let's start with the highest potential actually in this field, and it's still, I mean, the persons who have been accompanying us for many years know that we are in this area of magnetoresistive random access memory for a long time, and it never picked up. It never picked up because then the DRAM was always cheaper, faster. There was flash also used for that, and so but we do see, especially in China, and the Chinese are leading this area in R&D. We do see that the Chinese are moving very strongly towards resistive random access memory and magnetoresistive. So both are magnetoresistive basic technologies. And why do they do that? Because if you have very large data centers and you do a lot of computing, which you need for the AI industry or the AI deployment of technology, you have it's a very consuming for electricity. You have a high electricity consumption, and with MRAM you can reduce that to, I don't know, few percentage, because you don't need the electrical impulse to keep, or the electrical flow, the voltage, to have the transistor basically remember whether he's a 0 or a 1. With a magnetical impulse, you can change the transistor with a very fast and simple impulse, and it stays, meaning you don't have to deploy electricity at all the time, and this reduces the electricity consumption very much. So the potential in this, and what the Chinese are right now doing, the technology is there. The key is how fast can you basically change the transistors, how fast can you deploy that. And if they solve this, then MRAM will be a very big technology moving forward like hell. And we do know that some of the institutes have very good progresses in this area. So this will be the highest potential. Right now, we do see also very strong sensoring. And as I said, the inductor for voltage regulation, these are two areas which are right now actually very interesting, because it's very cheap, very efficient sensors based on semiconductors. So these are the areas. Who do we face? Well, especially in the MRAM area, there's also the large ones, Tokyo Electron and Applied Materials. They are in this area. However, we have good technology and we can be on niche areas. And one of those machines is between 6 or 7, 8 million, depending how it's customized and tailor-made. And you can imagine, selling like more than a handful a year would be a very lucrative and good market. So these areas, even if it was niche areas where we go into, that would be very attractive. So semiconductors is good, and these are the key areas. Hopefully I answered the question. So William, what else do we have?
Yes, the next one is actually on trading conditions. Can you give us some color on update on order entry developments over the past 2 months? And are you still confident in achieving your 2025 targets?
The markets are still very slow. We are working on several projects. And if we have significant order entries, we will inform the capital markets, of course, right away. So with ad hoc notices, if there's anything significant to do, then we will do that. We have our revenue recognition is based on IFRS and is based on IFRS 15, and we can do percentage of completion, meaning that once we have a contract in house, let's say a large order, we can already hand out to our customers, to our suppliers, we can hand out all the orders for the parts. And right now, then, if the parts come in for the project, we can realize and recognize on the POC the revenues. This is why for us, towards end of the quarter is critical. We have to see what is the order entry until end of the quarter, starting October, and we have to see what did we achieve in order entry. And once we achieve the order entry, how fast can we recognize and realize, and how fast do we have to do that, because the customer is always pushing them. They are always in a hurry. It takes long to sign the contracts, but once the contract is signed, then they want to run through the project, of course, as fast as possible. It's always like that. So then we can realize the revenues, and once we have realized those revenues, then when we know how we can realize those revenues, we know how much time we need, and then we will see whether we can achieve all the objectives we have given us for this year, or whether some of the objectives or some of the revenues have to be postponed into the coming quarters. We will have a look at that, and we are always watching and reviewing this very closely from the management side and discussing that with our salespeople. And if there's, as I said, significant things to know, we will let the capital markets know when we see those order entries.
Mr. Ehret, thank you very much. Unfortunately, we've run out of time, so we can't answer the last questions, but I guess they can be directed to you directly, or we also cover Singulus, so also feel free to direct them to our analyst, Abed.
Just hand them over. If we have the addresses, we will answer them anyways. Looking forward to that.
Great. Thank you, Mr. Ehret.
Let me thank you very much for participating, and I look forward to speaking with you next time also. Thank you very much. Have a pleasant day.
Thank you very much. Goodbye.